Okay, so 6.6 is all about using your newfound factoring skills to solve equations. Okay, essentially all the solving of equations we've done so far, whether it was with linear equations in chapter 2, or rearranging equations with two variables in chapter 3, or solving in chapter 4 systems of equations, have all been linear. So everything so far has been linear and has followed one strategy. We're now going to develop a different plan to deal with everything else that's a polynomial. Okay, and we're basically only ever going to have two plans on how to solve an equation. Either it's linear and we follow the steps we already know from chapter 2, or it's a polynomial and we'll follow these steps. Okay? Solving quadratic equations by factoring, the first thing you need to know, what all this is based on, is something called the zero product rule, and it's really important you get comfortable with this. Not so much that you know the vocabulary, but the rule is real simple. If A times B equals 0, then either A equals 0, or B equals 0, or both. Okay, and that is such an important foundational skill. That's how we're going to solve every polynomial equation. Okay. Using this one idea. And we'll quickly do an example so you know what I'm talking about. But this is huge. Okay, this doesn't work with any other number. Okay, if I have A times B equals 6, A and B could be literally anything. Well, that's not true. A could be anything other than 0, and then we could find its partner Y. Right? So for example, A times B equals 6. We could have 1 times 6. We could have -1 times -6. We could have a half times 12. We could have 2 times 3. We could have -600 times -100. Right? There's an infinite amount of possibilities. However, when A times B equals 0, you could not ever have two non-zero numbers multiplied together and get 0. Right? No matter what numbers you put here, if they're not 0, then you can never multiply them together and get 0. So this zero product rule is huge. If I have any things multiplied together that result in 0, then I know 100% certain at least one of them is equal to 0. And that's what I'm going to use, is I'm going to take a polynomial and factor it. So it's a product of this parentheses times this parentheses equals 0. And if I have a parentheses times a parentheses equals 0, then what do I know? Well, one of the two is going to be 0, right? Either this parentheses or this parentheses is 0. And so how many solutions will there be?
A lot.
0.
1, 2,
2. Either in this case, A is 0 or B is 0, right? Those are the two answers here,
or both.
right? Or you could have both, but we're just going to say A could be 0, B could be 0. If they're both 0, okay, it still follows that A is 0 or B is 0. Okay?
They're both 0, is it one solution?
Depending on how you're looking at it, yeah. In general, what we're going to get is, like, say, x equals 3 and x equals 7. so they couldn't both be true, like you can't have x be 3 and x be 7. But yeah, if you got x equals 7 for both of them, then yeah, there's only one solution, it's x equals 7. Yeah, so depending by what you meant by that question, yes. Okay, so that's the big idea. Now a quick execution of it, right below this, would be number 2, okay? So here's an example, number 2, solve using the zero product rule. Number 2 is x times x minus 3 equals 0. Okay. So here's how I see it. I see it as something times something else equals 0. So either this or this must be 0. Okay, so one of them has to be 0, otherwise it's impossible that their product when multiplied together equals 0. That's the whole idea. So what we say is we say either the first red box equals 0 or the second red box equals 0. Right? So that's my A and my B being multiplied together. So the entire reason we are going to use factoring is then when we have a product equal to 0, we just literally say, well, either the first thing 0 or the second thing, and if there's 10 things multiplied together, we say either the first thing 0 or the second thing 0 or the third thing 0 or the fourth thing 0 or the fifth thing, all the way through, and you would get 10 different answers if there were 10 things multiplied together. Okay? For almost all the problems we solve, there's going to be 2 things multiplied together. Okay? That's on my phone ringing. Making sure it's not my wife, but okay, it's not. I got crazy things going on in my house, so there could be emergencies. Okay, so plus 3, solving this, we get x equals 3. Okay, so our 2 possible answers is either x equals 0 or x equals 3. Okay, 2 possible solutions. Alright? Questions on that? Okay, I'm going to do a similar problem and then we'll work on some general steps. Okay, similar problem, number 4. X minus 3 times x plus 8 equals 0. How would we solve this?
With
Plus 3.
Well, not yet.
Well, don't you wanna,
Minus
like,
8.
do the
A and B
Minus
first?
eight.
Yeah, we need to do the A and B thing first, so what are we gonna write?
X.
X minus 3 equals 0.
Yeah,
Or x plus 8 equals 0.
exactly. So we need to say either this thing equals 0 times, or this thing equals 0. Because their product is 0. And that's gonna be your last step in solving every single one of these problems. The steps before are factoring. We did that, we're experts in that, awesome, we're not stressed about that. The steps before that, addition, subtraction, combining like terms, like, come on. Chapter 2, chapter 1. So the only new step here, one last step of this process is if you have a product equal to 0, you split it up and you say this equals 0 or this equals 0, and then you have 2 separate equations that you solve. Just like chapter 2, you say, oh, plus 3, so either x equals 3 or minus 8, you get x equals negative 8. And we could go back and plug this in, right? We could go right back and we could say, let's plug in 3. 3 minus 3 is 0 times 3 plus 8 is 11. 0 times 11 is 0. Check. That's a solution. Plug in negative 8. Negative 8 minus 3 is negative 11 times negative 8 plus 0, or plus 8 is 0. Hey, that's also 0. Check. It works. Okay? So, that's the big idea here. Okay? Now, just below this, just to give you some kind of general idea, okay? That's our big, like, general idea, okay? Is we need to factor a polynomial into a product that's equal to 0. That's what this is all about here, okay? Taking a polynomial that's a bunch of terms added together and then factoring it so that we have one product, one term equal to 0. Okay? And just to kind of point out one last time why we have a different strategy to solve, let's just think about x squared plus 3x plus 4 equals 7. I just made those up. I don't think it'll work out nicely or anything. Okay? Now, if this x squared is not there, we can move all the numbers to one side, all the x's to one side, and just divide, and we can get x all by itself, right? We can minus 4, 3x equals 3, divide by 3, x equals 1. Great! However, if there's an x squared there, okay, it looks a little different. Well, I'm still going to just move the 4 over there, okay? X squared plus 3x equals 3. How do I get x by itself? There's no way to get x by itself, because now I've got two separate terms that are totally different. X squared and x are different. There's no way to put them together with addition or subtraction. So there's no way now to get x by itself. Okay, so we need an alternate plan, a totally different plan to solve a polynomial, because we can't get x by itself anymore when there are multiple terms that are not alike. So, here's our big general plan. Alright. General steps, and I'm going to do it in two parts. I'm going to do over here is linear. Okay, AKA, this is chapter 2, this is old, this is good stuff, classic. Okay, and over here is nonlinear, AKA polynomials. Okay, two totally separate plans. Okay, first step in solving, distribute. Got it. Get rid of all the parentheses. 2, combine like terms. Got it. Okay. First step's over here. 1, distribute. Hey, that's nice. Second one, combine like terms. Okay, so it's still the same. But then they diverge, then they split. Okay, we already know the plan for a linear equation. I'll give you an example and we'll just go through the steps. Okay, 5x plus 3 equals 2x minus 9. How would we solve that? What would be our next step? We're assuming already the distribution and the combined like terms is done. Yeah?
When we move the 2x to, or the 5x to the 2x, and then you subtract positive 3 with negative 9
To get?
to get negative 12.
Or I mean just the big picture. To get, why did you do those two things?
Oh, so you can get them on two different sides and then get 0.
Exactly. So we add, subtract to get all the variables on one side. And numbers on the other side. Okay, so as Jeremy just said, we're gonna move the 3's over here, move the 2x's over here. You could do it in separate steps, I'm just gonna do it all at once. And so we get 3x equals -12. Great. Last step is?
Divide by 3rd.
Exactly. Divide by the coefficient of x. Okay? So in this case it's 3, divided by 3, divided by 3, we get x equals -4. So those two steps are gonna be the only things that are different. And our next step is actually gonna be similar. So I'm gonna put one problem up here and just work through it with you. So here's an example over here. 2x squared plus 5x equals x squared minus x minus 5. Okay, my next step here, instead of adding and subtracting to get x's on one side and numbers on the other, instead we're gonna add or subtract we want to move everything to one side with addition and subtraction so that it's equal to 0. Okay, so I'm going to move everything to the left, so minus x squared plus x and plus 5 to cancel all three of those out. So minus x squared plus x plus 5. Okay, so now I have x squared plus 6x plus 5 equals 0. Just moving it all to one side, that's all I did. Okay, I moved everything with addition and subtraction to one side so that it's equal to 0. Okay, the next step is factor. Alright. And I'll even put the reason there so that and the reason is so that you have a product equal to 0, right? Once you factor that left side, you have something times something equals 0. So factoring this, we get the sum is 6, the product is 5, so it's a positive 1 and a positive 5. So we get x plus 1 times x plus 5 equals 0. And then the last step is set each factor equal to 0 and solve for each answer separately. Okay. So those last three steps are all that's different, and this is it. This is how you solve every equation you will ever encounter in math. This is if it's linear. This is if it's not linear. Okay? Every equation you come across, you can solve in one of these two ways. Okay? So over here, this would become x plus 1 equals 0, or x plus 5 equals 0. So that would be minus 1, x equals -1, or minus 5, x equals -5. Okay. So just to reiterate, the big difference here is instead of moving variables to one side, numbers to the other to get x by itself, you move everything to one side, factor, and then set the factors equal to 0. Okay. Questions on that? The big reason we realized right away to use this plan is we see it's nonlinear right away because of the x squared. The x squared. So immediately we know, oh, I'm moving it all to one side to factor. Okay? That's the giveaway right away. So let's do an example. Okay? The example we did started at number 5. It had already done 1 through 4 for us, and so we started with something looking like this. Okay? So in math, the way we ratchet it up in difficulty is we add one extra step. Okay? So now we're going to start with a problem that looks like this. Then we're going to grow in difficulty, and we're going to start with a problem that looks like this. Okay? So we've already done 2 examples that looks like this. It was already a product equals 0. So you just say this equals 0, this equals 0. Now we're going to move to an unfactored polynomial, but it's already equal to 0. Okay, so number 9, I don't know why I chose an odd number, but that's good. So x squared plus 8x plus 15 equals 0. Alright, so what will we do first?
GCF?
Yeah, so we would factor in general. We'd say, what's the GCF? Oh, the GCF's 1. Bless you. So we can't take anything out. So next,
Count the term.
count the terms. We got 1, 2, 3. Oh, okay, so we're using either X factor or hokey pokey. And so we check. Oh, nice. It's a 1 out front. We get the easy method. And as I told you, that's going to be way more common. So get really used to that. Okay. So what's our sum? 8. What's our product? 15. So what are our numbers?
Positive 3, positive 5.
Yeah. Positive 3, positive 5. So we got x plus 3 times x plus 5 equals 0. And then how do we solve it?
X plus 3 equals 0.
So either x plus 3 equals 0 or,
X plus 5 equals 0.
yeah, one of those two is true or both, okay? So solve the first one, we get x equals negative 3 or minus 5, x equals negative 5. And we could plug these in and check. Let's go up to the top. Negative 3 squared, 9. Negative 3 times 8 plus negative 24 plus 15. Well, 15 plus 9 is 24 plus negative 24 is 0. Check, it works. Plug in negative 5. Negative 5 squared is 25. Negative 5 times 8 is plus negative 40. Plus 15. 15 plus 25 is 40. Plus negative 40 is 0. Check. We found the two solutions. In general, whatever degree the polynomial is, if it's x squared, there are 2 possible solutions. There might be 1, there might be 0. But there are a maximum of 2. And what we're going to solve for in this whole section are 2 answers. Okay? If they're the same, as Victoria brought up earlier, if they're both equal to 7, then there's only one answer. X is 7, right? You don't say x is 7 or x is 7, because that's just redundant. And we're not going to deal with any no solutions yet. As we start chapter 9, dealing with quadratics, parabolas, quadratic formula, then we'll look at no solution problems. But for now, we're doing it by factoring, so everything will have at least one answer. Oh, I'm going to leave the nonlinear polynomial steps and just erase the old news steps that we've already done. Okay, so let's do a couple examples that build in difficulty, okay? So now, what if we didn't have it all on one side? What if we had something like x squared plus 7x equals 18? What do we do?
subtract 18,
But why? Why?
so it equals 0.
Exactly. As soon as you see an x squared, you know to move it all to one side. Equal to 0. As soon as you see an x squared, you can think of just the squared or the whole x squared, but immediately, when I say solve and you see an x squared in the problem, that dictates this strategy, okay? That means everything to one side, factor. Okay, so as I heard, the steps were minus 18, okay? So I got x squared plus 7x minus 18 equals 0, and that looks a lot like number 9 now, right? So what will we do next?
Choose 0.
Well, yeah, but even bigger idea, just what are we doing now?
Factor.
We're factoring, right? So somebody other than Dan, help me out, how would I do this? Yeah, got
The
things.
sum is 7 and then the product is negative 18.
Perfect, and so what do we know about their signs?
Two are negative, one's negative, one's positive.
Yeah, one's negative and one's positive because the product is negative, so they multiply to make a negative. And so we only have 1 times 18, 2 times 9, or 3 times 6. And we know that since they're opposite signs, we add them together, they cancel, we're really subtracting. So these subtract to make 17, 3, or 7. So we're using these ones, and which one's positive?
7 or 9.
The 9, because we want the result to be positive. So there we go. So what's our factored version?
It's actually a 2.
X.
Woo, a 2! I was saying 7 out loud. Good catch. Classic. Okay.
X minus 2x plus 9.
Yeah. And then what do you do? Last step?
Either x minus 2 equals 0 or x plus 9 equals 0.
Exactly. Either the first factor equals 0 or the second factor equals 0. So add 2, you get x equals 2. Or subtract 9, x is negative 9. And again, you could go back up here and you could plug it in. Plug in 2. 2 squared is 4, plus 2 times 7 is 14. 4 plus 14 is 18. Check. Okay? Plug in negative 9. Negative 9 squared is, 81. So plus 7 times negative 9 is negative 63. Subtract, you do get 18. Check, it works, right? I love plugging it back in and being 100% sure I got the right answer. Feels good. Okay, I'm going to bring up one that is absolutely no different, but scares people and people panic because maybe it looks different. Okay, so 18. X squared minus 6x equals 0. Okay? So what do we do next?
What'd you say?
Well, I mean, yeah, big picture though. So, yeah, factor in general, right? It's already equal to 0. We already have it on one side. So we need to factor it. So as Frank said, we start with the GCF, which is? Yeah, so GCF is x. And so we get x times x minus 6 equals 0. And then?
It would be x equals 0 and x minus 6 equals 0?
Exactly. And this should be no different. The process is the same. People get scared because they see an x squared minus 6x, so immediately they're thinking of a 3-term polynomial. They're thinking, well, that's, x squared minus 6x plus something equals 0. What's that something? And I mean, if you wanna write something in there, go for it. What number is that? Yeah, 0, right? Okay, sure. If you want to write that in, write plus 0. And if you want to then solve it like a 3-term polynomial, go for it. Well, I don't know why you would, right? It clearly has 2 terms. But if you want to solve it like a 3-term, great, do it. Okay, the sum is?
Negative 6.
And the product is 0. And so what number is multiplied with 0 and add to be negative 6?
Negative 6 and 0.
Yeah, negative 6 and 0. So our factors are x minus 6 times x plus 0. And x plus 0 is the same thing as just x, right? So this is x times x minus 6, which is the same thing we got over here using just the GCF, right? So always go in that same order. Take out the GCF, count the number of terms, use the right plan. Okay? But yeah, so that shouldn't be any different. But for some reason, when things look a little different, people start to think, I'll just make up a different method. So having those general steps to follow is really helpful. Okay, so we could just do a couple more examples, but there's nothing else new. Let's just get really comfortable with these steps. There is another problem here that, again, don't get too creative here. Follow a good set of steps. This first part is a really common mistake. Okay, what should we do here?
Subtract 5x,
Yeah, because what do we want to do first?
get them all to one side.
Yeah, we want to get them all to one side equals 0 because we see an x squared in the problem, okay? What do you think people mistakenly do first here?
Divide for the x.
Yeah, so mistakenly people say, you know what? I'm just going to divide by x here, and I'm going to put a big arrow here and say this is wrong, so don't copy this as though it is correct. Okay, so we get 3x equals 5, so divide by 3, we get x equals 5/3. Okay, that seems like you got a good answer. One giveaway is you only got one answer, and there was an x squared, there should be two answers, but okay, you got an answer. However, okay, as I think Dan said, the way we're supposed to do it is actually, we're going to do it like a polynomial. Again, because we saw, there, I'll use a different color. We saw an x squared, so we're thinking we need to use this strategy. Okay, so first, and I'll solve it over here, so I have a lot of room, is I'm going to subtract everything to the left. So I have 3x squared equals 5x minus the 5x from both sides. Now I have 3x squared minus 5x equals 0. Then factor, right? And what's the first step in factoring?
GCF.
What's the GCF? Yeah, the GCF here is x. So taking out the x, we have 3x minus 5 equals 0. Then what do we do?
X equals 0, 3x minus 5 equals 0, figure it out.
Exactly. Write out the two factors equal 0. So either x equals 0 or add 5, 3x equals 5, divide by 3, x equals 5/3. So we get two answers. And oh look, one of them was right over here. Okay, but why was that step wrong?
There's only one answer.
Yeah, I mean, that's true. I mean, so you're saying the answer is wrong, okay, but why can't you do that?
You didn't have anything to compare it to?
Not quite.
You can divide by how?
You got the first half of the sentence.
You can divide by an x if there's a power to it.
Really close. You can't divide by x.
0.
Divide by 0.
Ah,
Denominator.
yes. Okay? So, the reason you can't do this, and I'll write it maybe in purple here, is avoid dividing by x when solving for x. X might be 0. And you cannot divide by 0. This happens, I wouldn't say often, but it is a common mistake. So I would just always say, avoid ever dividing by x. In this class, we're almost never going to do that, okay? I mean, the sort of maybe exception is if there's a fraction that has something like that. I mean, simplify, okay? But you should not say, here's an equation, I'm going to divide by x ever in this class. Okay, the reason is x is a variable, and x could be anything. Okay, and you clearly cannot divide by 0. So you cannot divide by a variable that could be 0. Okay, as a general rule. You can only divide by numbers. You say, hey, you know, this equation would look a whole lot easier if I divided by 2, or if I multiplied it all by 2. But do not divide by x. Same thing, don't even multiply by x. Okay, but I just wanted to be clear. Use the same plan for every problem. As soon as you see in x squared, you think, move it all to one side. Equal to 0. Okay, so I'm just trying to highlight a few common mistakes, but the same plan applies to all problems. So let's do just a few more quick examples. Here's one. Right, 30 is again, what do we do first?
Everything on one side.
Everything to one side. We see an x squared, so first move it all to one side. Okay, so now, right, we got x squared minus 14x plus 49 equals 0. Okay, first step, move it all to one side. Second step,
UCF.
yeah, let's factor in general. GCF, there isn't one. So next step, Richard?
Oh, then you factor?
Then we'll factor, okay, so there was no GCF, so the sum is negative 14, product is 49, so we know both signs are negative.
And you do that because the leading coefficient is 1, right?
Yeah, because the leading coefficient is 1, it's the easy factoring method with 3 terms. Yeah, if it was a 2 or a 3, then we have to do those both. Okay, so what are our two numbers?
X minus 7 sin x minus 7.
Exactly, both 7. So we get x minus 7 times x minus 7, and then we write
Oh, no, we write
X.
x minus 7 equals 0,
yeah.
and x minus 7 equals 0.
Ah, and this is one of those cases where we get x equals 7 or x equals 7. So really there's only one solution.
If they're squared like that, do we have to write both of them? 'Cause
Oh,
it's
no,
7.
yeah. So as I said, when you have an x squared, that basically means there can be at most 2 answers. But the 2 answers could be the same, meaning you really have just one solution. Okay? Alright, I think that's all the tricks. I want to show you one last problem that might come up. That again, shouldn't be any different, but people think they recognize things, and so they start to get a little too creative. Okay, x times x minus 3 equals 18 is 44. Okay, what should I do first?
Get everything in one.
Shh. Ask somebody else. You just helped me last time. Thank you for knowing it, Victoria. You're a rock star. Jess, how are you gonna do it?
Move it on one side.
Oh, but how can we move it to one side? Look what we got. But okay, let's do it. So how are we gonna move it to one side? Yeah.
Take away 18.
Yeah, take away 18, take away 18, okay. So we got x times x minus 3 minus 18 equals 0, okay? So you skip those 2 first little baby steps there. In general, when solving a problem, yeah, just get rid of all the parentheses, combine all the like terms so you don't have any of that to deal with. If you want to move it all to one side first, because you know it's going to clean up, like that's okay. So if we distribute this in, we get x squared minus 3x minus 18 equals 0. And then it's a normal, everything's normal, so you go, okay, sum's negative 3, product's negative 18, that's negative 6 and positive 3. X minus 6, x plus 3 equals 0. X minus 6 equals 0, or x plus 3 equals 0. So x equals 6, or minus 3, x is negative 3. So it shouldn't be any different than all the others. The problem is that people see this and they think, this looks nice and factored, right? That's what people think, and they think, oh, I'm already done? Right, but what's the big reason we're not done there? It is factored, that's as factored as that left side gets right now. But why are we not done? Why can't we solve it like that?
Because it equals 18.
Yeah, and what multiplies to make 18?
6
Yeah, what else?
9,
9 and 2, what else?
18
Oh.
times 1.
18 times 1, and what else?
1 and 18.
Yeah, 1 and 18, and? Negative 1 and negative 18? 36 and a half? Decimals and decimals, right? Crazy, there's an infinite number of possibilities. This entire section, the entire idea of how to solve for any polynomial, in the most advanced calculus class, when you've got y to the 7th, yada 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 yada, the way we solve any polynomial is we have to get it factored equal to what?
0.
0. If it's not equal to 0, it's almost useless. Okay, because this times this equals 18, there's so many different pairs. But this times this equals 0, like down here, there are only 2 possible ways to make that 0, and those are our exact 2 solutions. Okay, infinite possibilities, 2 solutions. That's why, even though this looks factored, because it's not 0, we're not done yet. Okay, we need it to be equal to 0. Alright, so that's a good spot to leave off. So, practice this right now, regardless of where you're at in the homework. Work on 6.6 right now. Try and actually solve some problems using this, and we'll spend a good 20 minutes or so on this, and then we'll take a little break, and then we'll do 7.1.